Welcome to MageCasts.io. My name is Fabricio Blanca, and this episode actually will be a little bit different than the ones you might have seen before. So this episode is not only about Magento, actually it's a lot more about making things. Making real things you can touch, making things that can interact with the internet. So in this episode, I want to show you how to hook this bell up to the internet so Magento can interact with it, and every time an order is placed, this bell will ring. And there's so many more things you can do hooking Magento up to like a real device. And of course, there's so many other uses for a bell like this one that you can post HTTP requests to make it bill ding. You can hook it up to your WordPress comments. You can make it ding whenever a tweet gets retweeted or when emails come in, or you can hook it up to Jenkins so that you know that a build is done or has failed, or there's a ton of things you can do hooking things up to Magento Store, both consuming data but also controlling data. You can hook up something like this analog voltmeter to Magento to show some real-time statistics in a nice way, or like a big LED display like this one, for example, showing you the current real-time lifetime sales, although I hope 4 digits are not enough for that. And yeah, so let's get started. So what are we actually going to use to make this happen? These days, the first answer to that would probably be the Raspberry Pi. So the Raspberry Pi came out a couple of years ago, and it's really nice and powerful, and it's only like, depending on the model, $20 to $30 or $40. You can run Ubuntu on it, and a lot of people actually use that for media centers. It has HDMI and audio and everything. So this is a real nice little computer, and you can do a lot of things with that. So the thing is, first of all, one thing that this cannot do very well is very exact timings with the GPIO pins. Since this runs Ubuntu or like a real operating system, the main purpose is not to be exact when it comes to timing. And also, this thing is kind of too good. It's kind of boring to interact with that, since this is what I'm doing all day long. Hooking into connecting to it through SSH, being on a real Ubuntu environment. So so this is why I don't want to use a Raspberry Pi for that. Then even better than Raspberry Pi is this. This is the BeagleBone Black. This is even faster, has more RAM and everything than Raspberry Pi, has even more GPIO pins, and you can do a lot more with that. I'm actually using this as a little file server, but again, this thing is way too good, and also similar to the Raspberry Pi, they are kind of too expensive for like a little device connected to the internet. So my goal is here to be minimalistic, to be as cheap as possible, as small as possible, and to consume only like power to possibly also run this device from batteries. So instead of going with the Raspberry Pi or with the BeagleBone Black, the next obvious answer would be go with an Arduino. And Arduinos are actually a lot of fun to play with. Arduino actually stands for a whole ecosystem of things. This is the Arduino Uno, which is definitely the most popular Arduino board, and this comes with an Atmega 328P chip, so really it's all about this. And Arduino also stands for the Arduino IDE and the ecosystem of plugins. And another Arduino in this family is the so-called Arduino Leonardo, which is very interesting because the USB port here can act as a keyboard and or as a mouse, so you can do a lot of interesting projects with something like that. But Arduinos, using an Arduino does not necessarily mean you have to go with one of those boards. There are different other form factors too. For example, there is this very nice Pro Trinket from Adafruit, which is basically the same processor that's on the Arduino Uno. And the Arduinos also come in different forms, shapes. For example, this is the Arduino Pro Micro, which is the same processor than the Arduino Leonardo. Then there's the Arduino Mini. But really, Arduino, it's all about the Atmega 328P chip, and that's it. And you can buy those for a couple of dollars, for like $1 or $2, and do your project with that. Actually, not going with a board like that, of course, allows you to come up with a lot smaller project cases. You can build them in a way that they consume very little power. Arduinos, these chips actually have different sleep modes, so it's perfectly possible to build a device that runs off batteries for weeks, months, or even years. And yeah, actually, there's another version of this Atmega chip. That's the AT-Tiny 85. It comes with a lot less I/O pins, but for many projects, this is already sufficient. And as you can see, it's indeed tiny. And yeah, so it's really interesting to play with these. And this basically allows you to come up with custom boards with the Atmega chip on it. So this is like a low power sensor node that would measure the light and this is the ambient light, or this is a soil moisture sensor, and it's hooked up. You can hook up a temperature sensor. So yeah, so basically this is what building projects, like making projects, is mostly all about. It's about like sensing things. It's about controlling servos or stepper motors and making things move. And yeah, so I mean, this might sound a little silly, but actually it's super exciting, so much fun. It's so interesting to learn about some of the lower level stuff, and it gets even more exciting as soon as it becomes wireless. So for the Raspberry Pi, you can actually get like a $10 USB dongle and make a Raspberry Pi wireless like that. And for the Arduino, there's actually Wi-Fi Shield, or there's actually an Arduino version, the Yun, that comes with like Ethernet connectivity. But a while ago, this thing came up. This is an ESP8266, and this is a super cheap chip that can connect to a wireless network, and actually also can act as an access point. And these chips are super cheap, so you can get them for $2 or $3 from eBay, and they come in so many different versions and form factors again. So there's this one, that's the ESP01, and then there's the ESP03, 05. There's so many different ones. For example, this one is the ESP12 that comes in a nice breakout board that's breadboard friendly. And then even more interesting is this one that actually is a working dev board that comes with a USB port, so you can easily hook it up and do things with that, and breaks out even more I/O pins. So you can use one of these to and connect it to your Arduino project, to your Atmega 328, and talk to it through a serial connection, and basically enhance your Arduino project and make it Wi-Fi, make it access the Wi-Fi network. But the very interesting thing is that this actually comes with a microcontroller as well that is pretty powerful. So you can do things only using this ESP8266 chip. And this is exactly what we're going to do now. So we're not going with a Raspberry Pi, we're not going with a BeagleBone Black, and we're also not going with any Arduinos. We're actually only using one of those ESP8266 chips, and we don't even want to connect that to another Arduino project, but we actually want to load a little program on this chip. So there's two different ways of doing that. You can actually upload a firmware that allows you to use this with the Arduino IDE, and the programs you would upload to Arduino are C++ programs, so you can actually use some of the existing libraries and use and create like an Arduino so-called sketch, which is a C++ program, and upload it to it. But originally, this is meant to designed to for you to upload a Lua program, and since this is so easy to do, we actually want to go with Lua and make this thing connect to a Wi-Fi network, and then remote control the servo, and the servo actually has a little stick that will then ring the bell for you. So let's look at the parts we need for this project. We obviously need an ESP8266, and of course you can go with a dev board like this, and actually there's the Hassa from Adafruit, and there is the Thing from SparkFun, and even this one, this Node MCU board. They all come with USB and make it incredibly easy to use that, but actually we want to go with the bare basic one. This one has only 2 GPIO pins, but that's perfectly enough for what we need to do, and it's super cheap. So this is what we're trying to do to use. So since this does not have a USB port, you need an extra device to talk to this, only to upload your scripts. So this is the regular serial interface with an RX and a TX line. So if you had an old computer with like a COM port, you can totally use that. But these days computers don't have that anymore, so you need like a USB to serial port converter. So this is an FTDI programmer, which basically is a simple USB to serial converter. So it comes with RX and TX lines, and shows up as virtual COM port in your computer. So you can select the COM port and to whatever program you're using to connect to this. This looks like a regular COM port. And with this in place, you can actually just use PuTTY to connect to your ESP8277, or actually there's a nice tool called eExplorer, which will come with some extra features and allow you to interact with that. So out of the box, this ESP8266 might come with an old firmware. So you would have to flash that chip first and upload a new firmware. I'm not going to show how this is done, but once you have everything in place and hooked it up correctly, this is not a big deal, but there's tons of tutorials and videos out there that show you how to do that. The firmware is open source. You can go and get it from GitHub and upload it there, and you'll have the latest firmware, can connect to it, and can basically, there's an interactive shell that is exposed through the serial port. So with PuTTY, you can actually play with that and program Lua right on that on this interface. So we talked about the ESP. So we also need a servo motor. So this is the SG90. This is a very simple, very cheap servo motor that comes with like pieces like this that you can snap onto that. And although I believe those are supposed to be used with 5 volts, this runs perfectly fine with 3 volts. So we're just going to use this, and this is strong enough to move this to actually ding the bell. Yeah, so this chip actually requires 3 volt, a 3 volt power source, and also it's not tolerant to 5 volt pins. And that's too bad, because USB is actually 5 volt. Some of the programmers, like this FTD one, actually allow you to switch to 3 volt, which is nice, because then you don't need any level shifter. So if you go and buy one, make sure you actually can set this using this jumper to be a 3 volt device. But even with the 3 volt programmer like this one, the current that's provided by this is not enough to for this Wi-Fi chip. So you still need an external power source, and if you don't do that, you might break this this chip, or it will simply not work as expected. You might run into strange problems. Of course, you could build your own 3.3 volt power supply using a voltage regulator, and actually I did that for the final product, then for the final board. But while developing, I really like to use these breakout boards. You can get them from eBay. They're really cheap. They're again like $1 or $2, and actually you can just put them on a breadboard, and you can here there are jumpers for 3.3 or 5 volt. So just set them to 3 volts and you're done and can play with. So then obviously we should have like a breadboard, so we can put everything there and we don't have to solder. Of course, later you might want to put everything on a piece of proto board like this one if you want to make it permanent, but that's outside of the scope of this tutorial right now. Then yeah, so you'll need a couple of wires to hook everything up, and that's it. So the ESP 8266 FTDI programmer, or another programmer that basically comes with like a serial port, a couple of wires and a breadboard and a servo motor, and then of course you need the bell. I got that from Amazon for like $5 or so, and you need a stick, something that you can use as an arm to actually push the button. There are other designs. Actually, there's another project out there that did something very similar with connected to a USB port that would ding that, and actually it's a lot more compact. What they did is they have like a little magnet here, solenoid, that actually pushes that trigger from inside. But we're keeping it simple. We will actually like physically make this thing like this arm move using a servo motor, and then so the first problem we have is that if you want to use this with a breadboard, that's not possible, since it comes with a 2x4 header pin, and if you place that on a breadboard like this, you will always short two headers, since on a breadboard all the rows are connected except for the power lines. They're connected this way. So there is no way how you could place this on a breadboard without shorting pins. So there's people suggesting to build something like this, which is a 2x4 header and like a piece of proto board and male headers there. And this is actually not really easy to solder. It took me like 3 attempts to come up with something that actually works and doesn't come with shortcuts. But then I realized you can get these 2x4 pins with those extra long legs very cheap on eBay, and that's basically the perfect socket. You can bend those legs and put that on a breadboard. So there's really no reason to attempt doing something like that. Just get a couple of those and bend them. So one of the problems with this is you get confused very easily if you look at the pins which one to connect. First of all, there are no labels here telling you which pin is actually which connection, and also you get confused when you look at that from the top or the bottom, and then which direction it is. So that's why I like labeling those. So I created these labels, and a PDF with this image is actually attached in the description of this video. So you can cut this and actually glue this to the socket, so it's really clear what label it is. That makes it a lot more easy to not confuse the connections. Okay, so I already hooked this up, and I'll walk you through the connections right now. You'll find the schematics in the image attached to this video, and so it should be really easy for you to follow. It's only a couple of connections. So this is the breadboard power supply. I set that to 3.3 volts on both sides, so that means this power rail and this power rail are both supplied with 3.3 volts. And the FTDI programmer also comes with power. So this pin here is the ground pin, and this is set to 3.3 volts. So there is a power. There is a VCC pin that provides 3.3 volts, but we're not using this one. But we still need to connect both ground connections from this power supply and the FTDI chip, and this is this connection here. So then the FTDI chip comes with an RX line and a TX line, and those go to, like, RX goes to the ESP8266 TX line, and the TX line on the FTDI goes on the RX line, so they are crossed. So let's look at the connections here. So we can see here's the socket, and I glued the labels on them. So you can see we have like BCC here and ground here. We have the two GPIO pins, and then here's the RX line. That's the blue one that goes to here, and on this side we have the TX line that goes on the RX line. And yeah, VCC goes to the VCC power rail here, and also the CH_PD pin also needs to be pulled up, so that also goes to the power line. And that's already it. That's all the wiring we need to do. So we insert the ESP622. Make sure you insert it in the right direction. We have two I/O pins available, GPIO 0 and GPIO 2, but we are only going to use the GPIO 2 pin, and so this is this one, and this is where we will hook up the servo motor. Okay, so now let's hook up the servo motor. The servo motor comes with 3 pins: ground, VCC, and the actual pulse pin. So a servo motor is driven using pulse width modulation, PWM. So that basically means that the width, the length of the pulse determines the position of this arm, the exact angle. So this is why it's super important to be very precise when it comes to the positioning, and that's why it's really hard to drive a servo motor with a Raspberry Pi without any additional hardware. Okay, so we'll connect black to ground, red to VCC, and the yellow one to the GPIO pin. So this goes here, this goes here, and this goes here. So now we've connected the servo motor. Now let's hook up the breadboard power supply, and this is an old 12-volt wall charger, and yeah, so let's connect it to this one, and you can turn it on, and you can actually see there's this tiny red LED here, indicating that now this chip has power. So the next thing we need to do is to connect the FTDI to our computer. So let's look it up. So now we hooked everything up. Now let's connect to it and start playing with it. So I recommend to download this tool called eExplorer. It works fine. It has some bugs here and there. It's still, I think, in an alpha version. And you can totally use PuTTY to just connect to it through a serial connection. But this tool actually offers some features that make it a lot more convenient to interact with that chip. So you can get it from here, from esp8266.ru eExplorer, and yeah, so actually this big button here is actually the download button. So if you click that, you can download it. It's a Java program, and here it is. Let's start it and connect to it. So you should see the COM port that your FTDI programmer registered show up in this list, and then you can click open, and this will actually connect to the ESP8266. The baud rate is important, so depending on the firmware that you flash, that might be different, but yeah, it's 9600 for this one. Yeah, so this is basically now an interactive Lua console, and down here, let's actually start with Hello World. So now this actually is being processed by this tiny $2 chip. This is Lua. Lua is actually not that hard to learn. It's pretty simple and lightweight. And yeah, now let's do some of the interesting stuff. So there's a pretty good blog post on the Adafruit website, which is of course meant to support their Adafruit Haza board, which essentially is an ESP8266 with all the other supporting hardware. Actually, it has something like the FTDI built in. This is this header here, and this blog post is really good. It shows you everything, how to hook it up through an USB serial connector, how to use PuTTY to connect to it, and yeah, some basic information about that. So actually now we're going to configure it. So first thing is we set it to be a station. So here, Wi-Fi set station. Oops, there's Wi-Fi set station. And now this is a nice snippet that actually will list all the access points. And in this IDE, we can actually load it here. So list AP, and then Wi-Fi STA get AP, and list AP as a callback. If we click save to ESP, send to ESP, it will upload this line by line and execute it in the ESP. And here are all the Wi-Fi networks that the ESP62 detected. So the next thing would be to configure it, Wi-Fi STA config, access point name and user password. So I already did that, so I'm not going to do it again. But yeah, you add the access point you want to connect to and the password there, and then hit Wi-Fi STA connect, and give it some time, and like a second. And this information actually will be written persistently on the chip. So even if it's disconnected from the power and you start again, this information is not being lost. So you only have to do it once. Then let's print the status. And this shows 5, and 5 basically means it is connected. And print Wi-Fi STA get IP will show the IPs in this network. So 192.168.173 is actually the IP of the ESP8266 on the same local network. Let's do some pulse width modulation, PWM now. So first we set it up, pwm.setup, then the pin is 4, although that's GPIO 2, then the frequency is 100, and then the pulse length, for example, here that's another 100. Actually, that's a number between 0 and 1023. So if we choose 512, we have exact 50% pulses. So let's go with 100. And now the PWM is set up, but it's not started yet. So we do PWM start 4, and the motor just moved. And it keeps moving because the ESP8266 keeps sending that pulse, although the motor already reached that angle. So we do PWM stop 4, and it stops vibrating. So now at this point, of course, we need to experiment with different numbers corresponding to different angles, because after all, we want to know how far up this needs to go and how far down this needs to go to actually push the button and go back up. So what we actually want is like a down-up movement. So you need to play with the different pulses here to find out the angles and also how long you need that pulse to be active, and how far you want to get back up now. So I've prepared that script for us that represents that server. So it's this. This is the snippet here. So we have the ding function, and here actually you can see I go down first. So PWM setup 400, then PWM start, then I'll wait for 300 milliseconds, and then I stop it, and then shortly after that I go back up, so 400 and now 150, which corresponds to a different angle. Again, PWM start, I wait for a little bit to give it time to go there, then I stop it. So with this function here, let me actually upload that. So you can see uploading actually means sending everything line by line and having it write to a file. So now the content of this window is written to a file init Lua, and that's actually the file that the ESP8266 will automatically execute after being connected to power. So now with this in place, I can type Ding. And now actually you can see every time I send Ding, this will move up and down. Okay, so let's look at the rest here. With this function here, we're actually setting up a server. So this is really interesting to see how simple a server can be. So this is not an Apache or an Nginx or anything that's close to being as powerful as those servers are. This is like really something that listens to an incoming TCP connection and executes a callback. So in this case here, we create a server listening to TCP. You can also use UDP here. We listen to port 80, and then we execute this callback. So in this callback, on the receive event, so it's all event-driven, we actually execute the Ding function here, and then we return a response header. So response header is another function here, which will actually return HTTP, then the code that we provided, and like a connection close and some information. And that's it. After this is sent, the connection will be closed, and that's it. With this IP address, we can now go to a browser, hit that address, and hit that, and the motor will move. So let me refresh that, F5, and every time I hit that, it will make the motor move. So obviously this is the minimal approach. So this is a simple get call, while really this should probably be more like a post, and I probably will want a different endpoint. Here I might want to pass a separate parameter or make that part of the payload to pass it a number. So we can remote control how many dings should be done in a loop. So this thing can parse that number and actually execute that many dings. And so there's a lot of room for improvement here, but that's the most basic version of that, where we just do a GET request to this IP address, and we'll make the motor move up and down. Yeah, and of course now this is a simple GET request, so we can use that from everywhere. We can use it from command line. You can have like a long-running import script, and at the end have semicolon curl this address. So you can step away from your computer, and once the import is done, this will do a curl request, resulting in this thing to move, and then resulting in this bell to actually ding. Or of course, what we are trying to do here is you can hook into Magento and have Magento send a GET request to this bell remotely when an order is placed, for example. So this does not have to be hooked up to your Magento store, like physically to the server that runs your Magento store. Of course, like in this case, this is now running here in this in my local network, so this IP is not accessible from outside. But of course, that can be configured in the router, or you can use proxies like ngrok or other services to expose that IP address from the outside. But that's a total different topic. So if you want this bell to be accessible from outside, that's like a networking issue that you need to solve. Yeah, so the next step, we will actually look at Magento. We will hook into some code where the order is placed and call this get URL. But of course, before we do that, we actually want to assemble that and mount the stick to it and make it actually do dings here. Okay, so this is what I came up with. This is the board from before. Now we actually don't need the FTDI chip anymore, since now this is standing alone and doesn't need to be connected to the computer. Actually, that also means we don't need the TX and RX lines anymore. So it's really the ESP 8266 chip connected to power and to the server motor. So here's the server motor, yeah, I mounted it on this little thing here, and this will be able to push the button and make a ding noise. So let me show you how this looks like. Okay, so let's look at it here in action. So here I have the IP address in the browser, and if I hit refresh, you can see this ringing. Or, of course, from command line, I can do a simple curl request, curl, and it will ring. Or do something like my import job, and then at the end of that import job, I'll do a curl. So we'll do that, and when it's done, just ring the bell. And yeah, so there's a ton of things you can do with this connected bell now. It's definitely before we actually get to Magento, I'd like to show you this. So I actually created a tiny proto board out of that. So what this is it's like a power jack with the tiny power regulator that will bring down the 5 volts connected to here from another old 5-volt wall charger to 3.3 volt. So this is a LM1117 power regulator that requires 2 capacitors. So basically all this part here is only making sure we have 3.3 volts. And then here's the socket with the 2x4 pin header. And then here I broke out the 2 GPIO pins with another ground and power rail here. So really this is just a tiny proto board that allows us to use an ESP8266, the ESP01 version in a tiny package. So we just connect it to here. So we have these 2 I/O pins, and we can connect the server motor to one of these I/O pins. So then I got these little project boxes, and this actually nicely fits inside one of those project boxes. I realized too late that I should have moved the power jack a little bit more to the front, but actually it still fits. So with this in place and the connecting it to the power, so this is not really screwed in, but this should work. We now have like a nice package that nicely would fit into this box and make this a nice compact thing. Of course, the server motor wires still need to go into that box and be connected. So yeah, so this is definitely a lot nicer than having a breadboard with this big breadboard power supply. So this is nice and compact, and that is more something that you could have sitting on your desk running. Okay, so now let's get this bell interact with Magento. So remember, we have a URL that we can simply call, and once we place a GET request, this will ding. And of course, this is very basic. There is no authentication. Also, it's not looking at any parameter. It's just like one GET call. Whatever happens, it will ding. The funny thing is that if you visit that the first time, a browser will usually check for a fav icon and maybe for other files on that server, which will result in additional dings. So it's definitely it definitely makes sense to add a little bit more logic on the server side to only listen to special URLs and maybe have this extra parameter in place where you can specify how many dings you want. So yeah, but let's keep it simple for now and let's look at Magento. So I've set up a simple Magento store, and so basically what we want to do is when adding a card to the product and checking out, whenever the order is placed, we want this HTTP request to happen. So basically, at some point here, after placing the order, we want this to happen. And so obviously this is not happening yet. And yeah, let's look how we can get this done. So the place to go would be the one-page controller. And there's many different places where you could hook into to make this happen. There's a couple of different events being dispatched here. And I think one of the options could be to use this checkout one-page controller success action. This happens after the order is placed. So this is basically, we are already safe here. And so we want to use this event to actually do the HTTP call. So in order to make this happen, let's write a simple Magento module. So here, that's the directory, the Magento directory. One level up, I installed Modman and N98 MageRun. So let's create the Modman dir here. And here we want to kickstart a new Magento module. So it's N98 MageRun dev module create. And then we say add models. We say Modman, and we'll call this MageCast Ding. So this will create the basic project structure for us, and so now we are actually ready to get started. While we're here, let's actually already install it. Deploy, deploy all, and now we should have the module in place. Here we go, MageCasts, and here's Ding. Okay, let's go to PHP Storm, and here's the module, and that was just created. So we have like MageCast Ding folder and here model, and let's create a class here. So let's just say observer.php, and here we'll call this MageCast Ding model observer. And this class really doesn't have to inherit from anything. And so what we're going to do here is public function ding, and here file get contents, HTTP. Let me look that up really quick. So this should already do the trick, the basic trick. So if we call this, this will do an HTTP GET request to this URL. Of course, it might make a lot more sense to do that with curls to have like a lot better control on the error code, the HTTP status code. But yeah, let's keep this as simple as possible for now, and just let's do the thing here. So the next thing we need to do is we need to listen to this event. Okay, so let's go back to the config.xml and add in that event. So we're here at frontend, events, then we need that observer name and observers. and then we'll call it MageCasts, MageCast Ding, and then let's add in the class. So our class would be MageCast Ding Observer, and then here we have a method, and that would be Ding. Okay, so let's clear the cache and see what happens. So let's add this to the cart. Let's go to the checkout. And so now let's see what happens as soon as I push the place order button. And here we go. So for whatever reason, there were 2 HTTP calls fired. Yeah, I'm not exactly sure what happened there, but that should be eliminated by actually not listening to every single call to that server, but to a specific call only. So now, while this basically already works, we're doing a synchronous call during the regular web request. And this is a very bad idea to do. I mean, this is a bad idea when it comes to integrating any other system. And of course, for something like this that might have any issues and it's not going to respond for like 30 seconds or so, you would not want to have the user wait for that long for the order confirmation page. So instead, what we're going to do is we want to actually move this into a very simple queue and have this processed in the background. So what we're going to do for this is we will actually go and install AVQ. AVQ is a very simple, a very basic queue implementation that's compatible to ZenQ. And out of the box, it is using a scheduler always task to be executed. So it's not very fancy, but it does the trick. So we're going to use this for now, and then we need the scheduler. So we install both of those, and then let's run modman and see what we can do there. So get modman, deploy all again, and then we run n98 mage run cache flush, and we run n98 mage run sys setup run to install them. Yeah. Okay. So now let's actually quickly look at AOE-Q. And so it's pretty easy to add a task to the queue. So this is how this works. So what we're going to do here, instead of calling the ding function, we actually will call the queue function. And here we will add a queue item instead. So the class here continues to be MageCast Ding and Observer, and the function now will be Ding, and we don't need any parameter here. So now what we want to do is, instead of calling Ding, we will call Q in our event. And this is pretty simple because the only thing that this does is adding something to the database. So this should be a quick and reliable thing to do. And so this is safe to do during the checkout process. So here, let's say Q instead. And yeah, let's clear caches. And now let's do another checkout. Add to cart. Okay, so no ding now because this is placed in the queue, and now we actually want to see what happens if we call the queue. So we have the PHP scheduler here, and AOA queue comes with a scheduler task. So here we go, AOA queue. Let's just run AOA scheduler manually. Action run now. Code AOA queue. So now, if we call this, the queue will be executed and the ding happens. Usually this would run would happen on a cron, and cron runs every minute or maybe even every 5 minutes, and that's probably okay. For your use case, you don't really want that to be a real-time thing, but for this example, actually, let's play a little bit with that and make this like a near real-time thing. And this is actually a feature that will be built into the AO scheduler pretty soon. But yeah, so what we're trying to do here is actually come up with some kind of a daemon that runs in real time. Yeah, what we're going to do is we will basically do a while true do, and then we would call the scheduler php scheduler dash dash action run now dash dash code and the code name, and then let's just put that to def null. Let's print a dot so we see something's happening, and let's say sleep 1 so we don't flood the database with requests while polling it. And yeah, so now we can see every second we basically run this task, and this is kind of what the daemon does, polling the database. So we now don't have the delay of up to a minute, and we don't have to wait for cron to come by and execute that task. So without changing anything in the code, let's add another item to the cart, and let's see how this hopefully now will ding right away. So adding something to the cart, going to the checkout process, continue, check money order. So, and let's see what happens here when I place the order. And here we go. Yeah, so this is a very simple example of how to have Magento interact with a device, and how to do that outside of the regular REST workflow, how to do that with a queue, how to use scheduler and AOA queue for that. There's a ton of things you can do to improve that, to make that a little smarter. One of the things that you can do here would be, for example, here we could actually listen to the order. So let's say here in queue we have the event object, and then the order ID that we just placed would be in event get order IDs. So this is actually returning an array with one element that's hard-coded in Magento core, so I'm not sure what the idea is behind that, but that's what it is. So with that in place, we could load the order, mage get model sales order, and then load the order ID. So now the order is the mage sales model order, and then from here we can get the order grand total. So grand total equals, and then here we could basically say we want ceiling of grand total divided by 10. So basically for every $10 spent, we would do one ding here, and then we could add that parameter to this task here, and then listen to it here, and actually pass that as a parameter over here. So yeah, the ESP8266 currently doesn't care about this, so it won't do anything with that. But yeah, this is a simple example of how to do a little bit more with that. Obviously, you would probably want this to be configured somewhere, not hard-coded. But yeah, you get the point. There is so many things you can do by connecting Magento to a device like this. And even if this is sitting somewhere else and it's not physically connected to a server, and even if that device actually is wireless, you can have this sitting somewhere on a desk in an office and have nice notification for orders being placed. Okay, so that's it with this screencast and with this tutorial. I hope you enjoy it. I hope you get the chance to actually start playing with microcontrollers, with Arduinos, with the ESP8266, and get into this whole topic. I think it's super exciting, and it's so much fun to do that. And there's so many interesting resources out there. Feel free to Google for things on how to actually flash the ESP8266 or how to combine the ESP266 with an Arduino project. And of course, you can use Raspberry Pis. There's a ton of things, interesting things to do there. And as I mentioned in the intro, since the Raspberry Pi is so much more powerful, it's actually a lot easier. You could even try running Magento on the Raspberry Pi. And yeah, check out the description and the blog post with this video. You'll find the schematics for the wiring. You'll find the sample code that I uploaded to the ESP8266 and some links to some resources I used to create this tutorial. I hope you enjoyed it, and bye-bye.